Welcome to another Big Data at Work webcast. I'm Paul Sonderegger, and today we're here with Andy Mendelson, Executive Vice President of Database Technologies, and for all intents and purposes, the man who owns the Oracle Relational Database. Today we'll be talking about databases, and in particular, NoSQL databases. Andy, welcome.
Thanks for having me.
So right now, there is this Cambrian explosion of databases, new species of databases evolving to fill new market niches. Why is this diversity happening now?
Well, we are in the era of big data, and we are moving from the past where we mostly were looking at lots of transaction processing data, lots of business data, to now looking at a whole new varieties of data like Internet of Things data. All the devices are sending out sensor data that people are capturing and analyzing. The Internet is full of data, from blogs to websites of various sorts. And everybody wants to look at that data and analyze it and use it to grow their business. Mm-hmm. The other big trend here is we have a whole new generation of developers out there. They're building these web-scale applications. And these applications are a little different from traditional business applications, the traditional transaction processing and analytics applications. Mm-hmm. They don't tend to always need transactions, for example. That's one of the big things. And they're looking at big scale, web scale. So they've also been innovating and looking at different ways of building applications to use this data. So
if we look at that specific niche, that mm-hmm. specific evolutionary niche of databases, NoSQL databases, mm-hmm. Help us understand what is the range of kinds of NoSQL databases, and what are they for?
Yeah, so the databases that people call NoSQL are generally for what we consider to be more simple applications. They're generally applications where the data is a collection of data objects, and that's it. There's no relationships between objects. They're not different kinds of data objects like you would have in a relational schema, mm-hmm. just a collection of objects. And the objects usually have a key and a value. That's the simplest case, just a bunch of bytes in the value. Or you can have a key and a document type, where the document might be like a JSON data structure. You could have a graph database where you're analyzing the relationships between things, where you just have nodes in the graph or the objects in this key value store.
Mm-hmm. So unlike in a relational database where your basic unit of analysis is a row in a mm-hmm. table, these NoSQL databases, they have different kinds of information things in them, object or a graph. Mm-hmm. And so just contrast those for us. How are those things different?
So relational databases are complex collections of multiple collections of objects, and the objects tend to have relationships between them. Mm-hmm. You have the famous foreign key relationships, parent-child relationships. And if you look at a typical schema for a business application, there are thousands of tables in them, and these tables have complex interrelationships between them. Hmm. The NoSQL databases are designed to address a much simpler problem, where you just have one collection, no relationships, and you're just analyzing data in this one collection of objects.
So these two kinds of databases sound very different from each other. Are NoSQL databases a replacement for relational databases?
No, the answer is no. So for relational databases, the core use cases are for running business applications, what we call transaction processing applications, or for running big analytic applications. NoSQL databases don't do that. Hmm. They are for dealing with large collections of simple data objects, where you have a simple application use case around them.
So it might help to talk about relational databases and NoSQL databases working together in order to bring this mm-hmm. contrast and complementarity to life. So can you tell us a story about these two kinds of databases in use together?
Yeah, so the history of relational databases is that they've, for 30 years, coexisted with other kinds of data management systems. There's file systems, mm-hmm. there's key value systems, and now we have the NoSQL systems that are really, are extending the use cases of previous file-oriented use cases around mm-hmm. data management. Hmm. These kind of products or data management systems have always been integrated and used together. So let me go through a couple examples. And my favorite example is Amazon. Everybody knows Amazon.com. We know they have this famous retail e-commerce site. Databases how like do Oracle, they use and relational databases like Oracle? So for many years, NoSQL database. So for many years, Amazon.com has used the Berkeley Amazon.com has used key value store in its key value store in its
which is underneath the Oracle NoSQL database. Which is underneath the Oracle NoSQL database. Is that right?
We use the Berkeley DB key value store. We use the Berkeley DB key value store as the core of the Oracle NoSQL database. So when you log into Amazon, the first thing it does is it pulls up your user profile. That's being pulled out of a NoSQL database. That just has all the information about you that it needs to continue your session on the site. When you look at the catalog on Amazon, that's being pulled out of a NoSQL database. When you start choosing items you want to buy, that's being stuck into a shopping cart, which is in a NoSQL database. But finally, when you want to say, okay, I'm ready to buy that shopping cart, let's purchase it, now that transaction is sent to an Oracle database, it's processed. You know, when money is important there, you want transactions, you want transaction processing, Oracle's hit there. And later on, as Amazon starts analyzing all the transactions on the system, all that information is flowing into an Oracle data warehouse, a massively parallel system that's analyzing what's going on, making recommendations for future purchasing, etc. at Amazon. So that's a clear classic example of how the two kinds of databases can work together. Another use case I'll talk about is one of our current NoSQL database customers, a big financial services company. It's processing credit cards. It's using the Oracle database as the system of record for all the transactions, credit card transactions that are being processed. But it's also using our Oracle NoSQL database as part of the credit card authorization process to validate that this transaction you want to perform with your credit card is not fraudulent. So it's using both kinds of database technologies together in that use case.
So it sounds like you've got some workloads where you have simple actions on simple data, and then you have other workloads that are about transaction processing with all of the, potential for rollback and atomicity and consistency that's necessary there, and that they're really solving two different problems, but when you put them together, the problem set that they can work on is much richer.
That's correct. And it's also really about, to make systems simple, sometimes it's good to use a simple solution that's just good enough for what you need, and not using a solution that is more complex than what you need to get the problem done. Right. So what people are doing is building very complex systems, and they're trying to minimize the set of moving parts and minimize or sort of maximize the reliability of the entire system.
So now you mentioned that there are different kinds of NoSQL databases. Let's talk specifically about the Oracle NoSQL database. And what makes the Oracle NoSQL database different from others available on the market?
Yeah, so for me, what I think is the key difference is the robustness of the product. Number one, at its core is Berkeley DB, which is a tried and true key value store that have been, this is probably the most popular key value store out there in the market. On top of that, we also support transactions. And in the NoSQL space, a lot of people crow about, oh, we don't have transactions. Well, personally, I think transactions are a pretty cool thing. And so what we have done is we said, well, there's some interactions with our NoSQL database that don't require transactions. You don't have to use them. But if you want them and you need them, transactions are really nice, because when things fail, transactions make sure things are really clean. And when you recover, you either have consistent data or you don't. And with transactions, you always have consistent data. If you use one of these NoSQL databases that doesn't support transactions, you have a mess to clean up after yourself.
So this is a big idea. So I mean, you've been talking about how, NoSQL databases are good for simple actions on simple data, relational databases, key for transactions. But what you just described is that one of the things that makes the Oracle NoSQL database different from other NoSQL databases is that it does transactions. So what does that mean?
So what it means is that if you have a simple application that's actually updating data, which you have to do at some point, you're loading data, it makes sure that every operation where you're doing updates is atomic, which means it either happens or it doesn't happen. And this is really what people call the atomicity property of transactions. If you have a database that doesn't do that, then you have something where when the system crashes, you get into a state where, well, maybe the transaction was halfway performed and or maybe it was performed at this site but not at that site, and you have a mess with the application developer has to try to handle. So it makes the job of recovering a problem for the application developer to deal with. They aren't really very good at doing that sort of thing, and so you really want to let the database deal with this kind of failure recovery.
So that's very interesting. The Oracle NoSQL database, unlike other NoSQL databases, does true transactions. But what else? What else makes it distinct?
Another part of the product that we think is really unique is performance. A lot of the NoSQL databases specialize in dealing with read-only transactions, and they give you really good performance as long as you don't do a lot of updates. Our product deals with updates really well, and so as you start adding more and more updates, the performance of our product stays really good, and we really stand head and shoulders above a lot of the other NoSQL databases in how we can continue to deliver great performance as you start doing more and more updates in your transactions. The other area I like to talk about is scalability. All the NoSQL databases will talk about how elastic they are. You can add nodes to their clusters, and you can get more capacity on demand and improve performance that way. We do that, of course, as well. One of the really nice things, though, that we think we do really well is as you add capacity, the system stays up and running, and the performance stays constant as you add more and more resources. It's all done with no downtime in the cluster. So we really are very proud of our performance and scalability of our Oracle NoSQL database.
No CTO or enterprise architect wants yet another silo of data. So how have you made the Oracle NoSQL database easy to integrate with the overall enterprise environment?
Yeah, so we've spent a lot of time integrating the Oracle NoSQL database with other data management technologies. Number one, the Oracle database SQL engine can be used to reach out into data in the NoSQL database and run SQL queries against that data. We've integrated our NoSQL database with Hadoop as well. You can do batch processing with Hadoop on the NoSQL data. Our Oracle Event Processing product has been integrated as well. So you can take your business rules that you're using for event processing and apply them to data on the NoSQL database. And finally, Oracle Coherence, which is our distributed in-memory cache, can use the Oracle NoSQL database as a persistent backend.
And then, as you mentioned, the Oracle NoSQL database appears in Enterprise Manager as just another part of the overall environment.
That's right. Oracle Enterprise Manager, which is the management tool our admins know and love for managing all the Oracle products, can also manage the Oracle NoSQL database.
So now, if you could give some advice to the CTOs, enterprise architects who are thinking about building applications that rely on NoSQL technology, what kinds of issues and considerations should they be thinking about?
Yeah. So the first thing that people should consider is, they've already, using the Oracle database to run a lot of their complex systems in their companies. And, Oracle databases obviously are general purpose tools. They can do everything a NoSQL database does. So the first thing they want to figure out is, okay, do I want to introduce a new technology into my environment? I have to train my developers. I have to train my administrators to manage this new technology. And, I think that's the first thing to consider. When they decide they want to make the jump and they want to add NoSQL technologies into their systems integrations, they should then sort of look at very carefully, there are various products out there. We think that the Oracle NoSQL database product is a really best-of-breed technology out there. It's well integrated to the Oracle environment they already know and use, so we think it's something that they should definitely evaluate and consider. And then finally, these complex systems, it's also, a lot of what's going on is data integration. As we saw in the Amazon use case and the credit card processing use case, there's a lot of data flowing between relational databases and NoSQL database, back and forth. And so you want to make sure you have products that integrate well together. Of course, the Oracle products and our NoSQL database product, as we mentioned before, are very well integrated and can help you simplify the design of these complex systems.
So you've been following the evolution of databases for a long time. As a matter of fact, you have actually directed and created a lot of the way that databases and the market have evolved. So what is your perspective on how the NoSQL market will evolve?
Yeah, so we relational database market is not going away. It's $30 billion. It's going strong. SQL maybe went out of fashion a couple years ago. It's back in fashion again. It's not going away. It's a great technology. The NoSQL technology, as well, has been around for quite a while. The ancestors of NoSQL databases go back 20 years. So that is also here to stay. It also fills a useful niche in the data management family of products that people are going to use. As these products mature, they will start adopting some of the enterprise class technologies that relational databases have. Security in particular, I think, is a big area where the enterprise customers are going to demand major advances in security. All the usual stuff like backups and reliability that relational databases have, I think the NoSQL databases will also be picking up. Things like transactions, I think the NoSQL databases are going to gradually pick up. I think we're way ahead in that space. I think the other NoSQL vendors will be looking at adding that as well in the future. And I think what you'll see, as this whole big data area continues to unfold, I think there's a great future ahead for both relational databases and the NoSQL databases.
So let's say that a company wants to get started using Oracle NoSQL database. How do they do it?
Yeah, so the easiest starting point is we have the Oracle NoSQL Database Community Edition, which is available for download on oracle.com. It's free. You can use it without any licensing from Oracle. If you start using it and you go production and you want to get support, Oracle will sell you support for the Community Edition at $2,000 per server per year. Really good deal. Beyond that, if you're an Oracle Enterprise customer and you like buying our Enterprise perpetual license purchasing model, you can buy the NoSQL database using that model as well. And get all the usual Oracle support as well as part of that model.
So you can start simple and then grow from there. You could also start with a full enterprise deployment if that's what you're ready to do.
Right. And one of the really nice things is that we also have the Oracle Big Data Appliance. Oracle Big Data Appliance is an engineered system that runs our Oracle NoSQL database at really high performance. And so if you want to start kicking the tires with the Oracle NoSQL database, you can just buy the Oracle Big Data Appliance and you're ready to go.
That's a great way to begin. It's also a great way to finish.
Okay, thanks, Paul.
So Andy, thanks very much for being with us.
My pleasure.
And thank you. Thanks for joining us for another Big Data at Work webcast, and we look forward to seeing you at the next one. Till then, bye-bye.
Thank you, Andy Mendelson and Paul Sonderegger. At this time, we will continue to address questions submitted via text using the Q&A box in the next 10 minutes. To submit a question, you may type it into the Q&A box, which again is located to the right of the slide area on your screen. Also, don't forget to register to attend the next episode in the Big Data at Work webcast series, Responding in Real Time. That is taking place on Tuesday, March 25th at 10 a.m. Pacific Standard Time and 1 p.m. Eastern Standard, as James Taylor, CEO of Decision Management Solutions, discusses his latest research on why using big data for real-time responses must detect, analyze, and act with greater automation.